Hi, I want to take a look at the link between the coefficients of linear thermal expansion, volume thermal expansion, and areal thermal expansion. A lot of people think that if you have a linear expansion, then you end up cubing or squaring the coefficient in order to figure out what happens with volume or area expansion. However, it turns out you're not squaring, you're multiplying. And here's how that works. So say I have a uniform sphere, a constant radius r0 everywhere. Well, the volume of that sphere would be 4/3 pi r0 squared. Now if I add some temperature, that radius is going to increase. So I would have a new radius that's equal to my original radius plus my change in radius, and delta r over r0 is going to be my coefficient of linear expansion alpha times delta t. But my change in volume isn't based on that change in r cubed. What I end up getting is a new surface that has a small thickness delta r to that. So my change in volume is going to be the surface area that I have, 4 pi r0 squared for a sphere, times my extra radius delta r. So delta v over v0 is going to be the coefficient of volume expansion times delta t. 4 pi r squared delta r over 4/3 pi r0 cubed ends up giving me a factor of 3 times delta r over r0. Delta r over r0 is alpha delta t. So my volume expansion times my change in temperature is 3 times my linear expansion times my change in temperature. So my coefficient of volume expansion is 3 times my coefficient of linear expansion. Now for the area, if I have a 2D circle, the area is pi r squared. If I increase my radius, I get an extra ring on the outside of that circle that's equal to the circumference of the circle, 2 pi times the original radius r0 times delta r. So if I calculate delta a over a0, that would be my coefficient of area expansion gamma times delta t. 2 pi r delta r over pi r squared gives me 2 delta r over r0, which is 2 times my linear expansion coefficient. So my area expansion is 2 times the linear expansion. My volume expansion is 3 times the linear expansion. So my area expansion is 2/3 of the volume expansion, and the volume expansion is 3/2 of the area expansion. Thanks for watching.